Hello everyone, this is Srinivasan from RMD Engineering College. I'm going to talk about K-means clustering algorithm in this video. See, the K-means clustering algorithms is used to group K objects based on the attributes into K partitions. And the important constraint here is the number of groups that can be formed from the K data object is less than n. It assumes the attributes of the data points can be used to form a vector space. And these algorithms partitions the total K points into K disjoint subsets. So here the number of groups that can be formed from these clustering algorithms is a non-negative number. And this K-means clustering algorithms is used to minimize the sum of square of distance between the data and the corresponding data centroids. Let us see the flow chart of this K-means clustering algorithms. Initially, it select K centroids, then it find out the distance between the K centroids with all other non-centroid points. Then it groups the data points based on their closeness to the centroid. See, after the group formations, the centroids will be updated, and based on the new centroid, the new group will be formed. This process continues till there is no change in the centroid. So this slide shows the steps of the algorithms in the pseudocode form. So it selects K objects from D, the total number of data points. Then it assigns the data points to the appropriate cluster based on their distance between the centroid and the point. See, once the clusters are formed, it updates the clusters, okay, by calculating the means of the cluster. So this process is repeated until there is no change in the clusters. Let us take a very simple example to understand this K-means clustering algorithms. Here I take 8 points and I assume the number of clusters to be formed is 3. And I selected these 3 points A1, A4 and A7 as centroids. Then I choose the distance measures. Here I am using the Manhattan distance for measuring the distance between the points. See, so now I take the all 9 points, I omit the centroids and I find out the distance between the points and the cluster heads. So based on the closeness, minimum distance, the clusters will be identified for the point. So the point will be placed in the cluster, which is located, which very close to the point. See, after the formations, the cluster, the mean is calculated, uh, and the mean values will be used to update the clusters to cluster head or centroid. Then, after the updations, we again calculate the distance between the centroid and all other points, and based on that, we assign a cluster for the data point. So this process is repeated till there is no change or movement of members or data points from clusters. Look at the weakness of this K-means clustering algorithms. So the initial formation is very, very important and it will decide the performance of these algorithms. And for every run or execution, it produces the different results. So it will produce the inconsistent results. And when the input is changed, so the placement of data field in the input data set is changed, it will affect the results. And it is very sensitive to outliers. So look at the important applications of K-means clustering algorithm. Its computational complexity is order of TKN. Here n is the number of objects, k is the number of clusters, and t is the number of iterations. And we are using the K-means algorithms in acoustic data recognition and vector quantization and image segmentations. We are using K-means algorithms for identifying the region of interest. Thanks for watching this video.